Good morning or good afternoon, everyone, depending on where you're joining us from, and welcome to today's webinar. My name is Kyle from Business Review, and I'll be your host today. It's our pleasure to have Precognize with us, who are presenting this webinar entitled Plant Manager, What Can AI Do for You? Today's guest speakers are Shen Lincheski, CEO, and Layat Avador-Pileg, CMO. I'd like to welcome you all to our webinar platform On24. You'll notice that this webinar is browser-based, so if you disconnect for any reason, please just click on the link you received by email to rejoin the session. If you want to ask any questions, you can send them in via the questions widget. Just type them into the box at the top left-hand corner of your screen and click Submit, and we'll have some time at the very end to address any questions or thoughts that you may have. Please use the yellow help widget if you require any assistance, and you can move, resize, and maximize any of the windows in front of you to get a better view of the slides. But for now, please allow me to welcome Shen Lincheski. Over to you, Chen.
Okay, thank you, Kyle. Thank you all for joining and taking the time to listen to this webinar. We'll talk. We'll try to give you a little bit of a feeling of what's behind the big buzzword of AI and what it can do for you. But before I'm doing that, just a word about us. Precognize is an Israeli company. We are a part of the Samsung Group, and we're active in the field of the process industry, mainly chemical, petrochemical, refineries, a little bit of steel, cement, pulp and paper. But this is our core industries. And this is our focus, and we believe that these industries have a very specific characteristics which are relevant for a specific type of AI solution, which we are providing. We like to call our software solution named SamGuard as a predictive monitoring solution, and I'll talk a little bit about why we're using this term and not the other terms which are sometimes heard in the industry, like predictive maintenance and so on. And the main reason for doing that is because we try to understand what our customers actually need. Okay, so before I'm going to how does AI work or what do we do with AI, let's start with your problems, with the things that you're facing in your daily life. And what we have found is that most customers, at least at the current market conditions, are mostly concerned about how they can produce more and not so much concerned about how can they save on the maintenance cost. Now, this is very different from, periods to periods. I remember in the early, in the beginning of the decade, people were mainly focused about cutting costs. Today, the main focus is about more production. Okay? So whatever we do in terms of technology and beautiful analysis of data, the end result of that should be around more production. And by more production, we refer to the generally used term of OEE, which is availability, less failures, better performance, and of course all the issues around quality, which are mainly relevant in batch production, but are also in continuous plants. So this is the overall goal of what we're doing. Okay, we're looking to ways that will enable you to take the data and eventually improve your OEE. Now, if we take it into more actual doable things, we're usually looking at equipment failures. Okay, can I tell you day, a week, maybe 2 weeks in advance that the certain equipment is going to fail, a pump, a valve, or something else? Can I use your quality measurements and other measurements which are offline together with the production data in order to tell you in advance that your quality is not going to reach the targets that you set, which is again something that we do, and I'll talk a little bit about that later on. Issues around deviation in the process. You want to keep the steam consumption and the production in a certain ratio, and you cannot keep that ratio, and you don't understand why. So those are also things which we try to help our customers to achieve. And overall kind of things which I put under the title of suspicious operation, but it's actually when the operation of the plant, which should be repeatable, is actually very dependent on the operator and the specific performance, and these are things that we want to monitor and highlight. And today these things are going unnoticed, but actually with the use of AI, we can actually highlight those things to management. Okay, so if you relate to any of these topics, I mean, if you have equipment failures or process deviations or quality issues, or you want to balance your operation, this is the right place for you. Okay, this is what we're trying to do through the use of our technology and through the use of AI. So let's see how AI can actually help us accomplish those goals. Okay. And when we started to prepare for this webinar, we kind of asked ourselves, what is AI? And there are many buzzwords around it, and all these talks around AI and machine learning, and whether AI will remove jobs and so on and so forth. And I do not want to really go into the definition of AI versus other methods. I don't think this is very valuable, and there are many definitions out there. The one thing I do want to say, and I do want you to remember, is that there is no magic. Okay, it's not kind of hocus pocus that will work and immediately you'll get some kind of results that will bring you to the goals that we've discussed. Yes, there is work to do. Yes, there is a person in the loop, especially in the process industry. It will not eliminate the place of the people, at least not for the foreseen future of the next decade, probably. Okay, and probably even more. So it's a great buzzword. And if I need to characterize a little bit what does it do, we basically take historical behavior, in this case, historical behavior of the plant, okay, and we try to understand what is the pattern, okay. Now, then we try to apply this pattern to the current behavior of the plant and see if something is changing, if something is not in the right way. And then continue and learn and relearn from the new patterns. Okay, because some of the new patterns that you've created are actually good ones. So we want to continue and learn and update the behavior that is accepted by the AI. Okay, so in that respect, it's basically learning from the history, applying it to the current behavior, and continuing and learning as this current behavior is becoming our new history. Now, when we talk about process plant, we talk about a little bit different environment that the environment other AI practitioners are seeing. Okay, and I wanted to highlight that through kind of a comparison to what happens, for example, with Amazon. Okay, so when I'm buying shoes, Amazon tells me, listen, customers that view this item also viewed other items, and there is very sophisticated AI algorithm there that kind of recommend the right recommendation based on basically who I am. Okay, so Amazon knows me to some extent. Okay, and based on that, they do some kind of recommendation. Now, the one thing that Amazon doesn't really know is that actually my decision whether to buy this shoe or another shoe is actually influenced very much by my wife. Okay, she's actually calling the decisions on buying shoes. And I don't know how you, it's in your family, but this is the situation that I live, and sometimes it's even my daughter is involved, so it's actually a kind of family recommendation. Okay. Now, when the AI of Amazon is analyzing my behavior and trying to match it, they're actually trying to match it to similar people with similar characteristics who did other decisions. Okay. But Amazon doesn't know that in my case, I'm very much influenced by my family. They wish they could. Believe me, if there is one thing that can improve their analysis, it's the understanding of all the surrounding around me that influence my decision. Okay? But actually, this is their situation where they don't know the surrounding. But in the situation that we're talking about, in plants, you know the situation. You understand the entire plant. You know that you have valves and pressure vessels and boilers and compressors and catalysts and reactors, and you know that you open this valve and the level of the liquid in the tank will grow, and if you open another valve, it will decrease. You know the situation for everything. So if you're trying to recommend something to this reactor, actually there is no reason whatsoever to only look at this reactor, because you have this information, which Amazon doesn't. Okay? And more than that, you actually have data for all these instruments and equipment within your plant. So you're currently collecting data from thousands of sensors, valve position, set point, flow levels, temperatures, of course, sometimes vibration, and so on. This data is already going through the DCS and is stored in the historian, and whether you are using our partner OSIsoft with their Pi historian, or you're using any other historian, this data is there. Okay, so you have a plan, okay, and you have data about every single equipment within your plant. So the first takeaway about applying AI, especially in the process industry, which is different from any other situation, is that you want to take as many influencing parts into consideration. And the first mistake that people do when they implement AI solutions in process plants is that they focus on one thing. If you focus on one thing, first of all, your results will be not as good as if you're taking the entire environment and everything that can influence the same thing. Okay? And we have a benefit because they don't know what's the environment, but you in your plant, you know exactly how things are connected. Okay? So if you manage to inject this knowledge, this connection, together with the data into the AI, this is the right way to go. And I'll talk later on how exactly we're doing that. On the other hand, Amazon is selling to billions of customers around the world, okay? And they have probably millions of deals where they're selling shoes or books or computers or whatever, okay? So their situation on the other end is much easier than our situation in the process plant, because they have many users and they have many buying decisions or purchasing decisions. Now, in our case, in plants, okay, we have several pumps and several valves and probably few reactors and some more things in our plant, but statistically, it's nothing to compare to the billions of users that Amazon has. And more importantly, when they have millions of buying decisions to run the AI through, actually we have very few failures or cases which we can learn from. Because if we talk about equipment failures, okay, a pump probably failed once or twice, and once it was in winter under certain conditions, and then it was in summer under different conditions. So actually, you cannot learn from one failure to the other. Okay, you had quality issues. Hopefully, you have quality issues over 2, 3, 4, 5% of the time, which is very, very limited learning compared to what Amazon has. Okay, so on one hand, we have a huge benefit that we know the entire plant, we know how things are connected. Okay, but on the other hand, we don't actually have many cases of failure, and this brings us into a very significant problem when we want to apply AI. Because the AI, the idea is that you can have so many cases, and based on that, the technology, the algorithm can learn. So what we have to do when we implement AI in the environment of plant is actually not to understand the pattern. Okay, I don't want to understand when pumps are going to fail, because I can't. Or maybe I want, but I can't because I don't have enough history, enough cases to understand that pattern. So what we need to do is not to understand the pattern. We need to understand the deviation from the pattern. Okay, we're not trying to find out when the pump is failing. We're trying to find out how the plant usually works. Okay? What are the different operation modes of that plant? What are the different situations that this plant is working for, and what is, let's call it, normal for that plant? Okay. Now, when we're doing it with our algorithms, okay, what we basically do, we take historical data, and by historical data, remember, the one really nice thing about AI is it's keep learning and learning and learning. So historical data means what we have from now a year back, but also from next week it will be another week and a year back. So we all the time take the fresh data, which become historical, and the algorithm is all the time learning from the new things that are happening in the plant. Okay, but we take this historical data and we put it into the machine learning engine. Okay, and machine learning, just to not to confuse between the different buzzwords, machine learning is usually envisioned as a subset of the AI, one of the AI techniques. Now, basically what this engine is doing, it's running through all this huge amount of data, those thousands of tags, something that a human cannot do under any circumstances as genius as this human would be, okay? And try to determine which situations happened enough times in the past so they would be considered normal, okay? So in this case, the situation where tag 1 was in certain values while tag 2 was in another value, while tag 3 was in different values, tag 4 was in different values, and so on and so forth. This situation happened enough times in the past, so the algorithm determines that this situation is normal. And there may be one normal situation, but usually there are many normal situations. Okay, it can be maybe you manufacture different products on the same line, or maybe you have seasonality in summer and winter, it's different normal behavior, and so on and so forth. So imagine we take all the tags, all those thousands of tags, okay, and allow AI to just run through the data and determine by itself what are the normal situations, okay? Now, we don't ask you what's going to fail. We don't ask you what can go wrong. We don't ask you what the operation limits. We don't ask you for anything other than the one assumption that we make is that most of the time your plant was operating normally, okay? Now, those normality clusters are actually going into what we call baseline machine learning model, which of course is being updated and updated and updated on a daily, weekly, and then so on basis. Okay. So what this allows us this allows us to basically determine that if suddenly tag 2 is outside the cluster while others are within, it means that there is something not normal happening with tag 2. Okay? And by the way, just to put a comment here for the more advanced or analytical people in the audience, when I'm talking clusters, it's not necessarily that we're applying clustering techniques. There are several techniques that we apply within the tools in order to come to this conclusion: what is normal and what is not normal, and it may be, everything from neural networks to deep learning and so on. Okay, but the output of doing that is that we cannot say people who bought this shoe actually, or people like you actually were most likely to buy this shoe. We're actually saying something here is not normal. If something here in the specific point in time is outside the expected pattern. But now we have another problem. Okay, because it's great, we have things which are deviating, but all of you are operating or involved with process plans, and you understand that deviation from pattern is actually happening all the time. Okay, every minute you have deviations. Nothing in the process plan is exactly like it was in the previous year. Okay, all the time there are deviations. So the key here is actually not to say there is a deviation. The key here is to say there is a meaningful deviation. Okay? And that's the real challenge that we have when we apply AI solutions to process plans. Because to run all kinds of algorithms, very, very, very sophisticated algorithms, and the data and come with deviations or anomalies, it's very easy. And you can download algorithms from the internet and you'll get hundreds or thousands of anomalies. The real question is how do we take the meaningful ones? Okay. Now, option one is, of course, to show it to the user, to our process engineer or whoever else in the plant, and say, this is an anomaly. Is it meaningful, not meaningful? And actually create here, without noticing, those millions of cases where we know, yes, this is meaningful, this is not meaningful, and maybe by that learn over time what is meaningful, and maybe by that eventually get to a situation when we show only the meaningful alerts. Okay. From our experience, or from experience in other fields, this is a very, very, very long process, very tedious process, and and a process that can apply only to very, very specific problems. Okay. So if you're planning to actually start showing anomalies to your user, to the process engineer, or other people, or even the control room, which is even worse, and try asking them, is it meaningful, not meaningful? It'll come with hundreds or thousands of anomalies every day. You're most likely to fail. Okay, they will say, this AI is not working. And remember, as I said in the beginning, there is no magic. Okay? If I don't have these millions of buying cases, I need to produce it from somewhere else. Okay. So this is an option. It can work if your users are really into working hard. Okay. But what we came to conclusion is that using this, showing anomalies and saying whether it's meaningful or not meaningful is a very tedious job. And what we are doing is to do something else during the implementation, and I'll talk about it just in a few slides. Okay. So remember this, there has to be some way to say what's meaningful and what's not meaningful. You have to address it. It's just a matter of how, And the way of asking the users to do it is something that, from our experience and from what we see, is not something which is feasible. Now, before I talk about how we do this, how we take this meaningful, not meaningful from the users in those 2 weeks implementation, I want to talk about another aspect where we as the process industry are different from Amazon. Okay, and this aspect is around the things which are surrounding us, the processes that are surrounding us. And just to give you an example, when I'm eating before I'm doing a buying decision, my decision is very different than when I'm hungry. Okay, there are those people who are very much influenced by this process of eating and feeding food into their body. Okay, now Amazon doesn't know that I ate or didn't eat. Okay? And they have a disadvantage because when they're trying to make a recommendation for people like me, actually, there are 2 people like me. There are people like me when I ate, and people like me which are now hungry and take decisions completely different. And maybe here they should have offered me something completely different. Okay, so this is their fault. They don't know what the influencing factors are. Now, in our case, in the process industry, we do know that. We know exactly what is feeding the reactor, okay, exactly to the extent that we're measuring, of course. Okay, we know when it stopped. We know what is the pressure there. We know everything about everything that is happening there. Okay, so if to summarize this, on one hand, we have a lot of information about the processes that are happening within the plant. We have a lot of information about the parts and how they interact with each other, which Amazon doesn't have. But on the other hand, we don't have the historical cases, those buying decisions that Amazon made, that Amazon has, that will help us determine what is actually meaningful and what is not meaningful within the outputs that the AI is bringing us. Okay. So what we need to do in order to determine this, or what we did in our case with the SamGuard platform, is that we decided, listen, there is a limitation to how much AI can provide us. Okay, it can analyze the data and run through thousands of sensors and determine which are the normal clusters and come with anomalies and everything. But they don't know what is related to what. They don't know what's influencing what. They don't know what the process is in the plant. If we found a way to actually take this knowledge, which you have, and inject it into the machine learning, into the AI, then we have a perfect solution. Then we enjoy both worlds. We enjoy the world of AI, and we enjoy the additional knowledge that you have, and can compensate on the fact that we don't have any historical cases of failures. And that's exactly what we did. So basically what we did is that we created an ontology, a language, a way to very rapidly describe a plant. Okay? And this way is basically composed of the minimal set of knowledge that we need from you in order to make AI smarter. Okay. Now, this set is basically compound of the data that you have, the structure of your plant, and where things are measured, and since we're in the process industry, what are the main processes within your plant? Okay. Now, the overall is reached by actually making a link between the things which are involved or influencing each other things through a process. Now, it may sound to you complicated, but actually we have done this process through tens or hundreds of plants already, and from our experience, a typical plant, chemical plant, significant chemical plant will take like an effort of 2 weeks to create this model, and it's inevitable. Okay, unless you really want to go anomaly by anomaly and mark which one is meaningful and which one is not meaningful, you have to add this additional knowledge to the AI. Okay. So what we created here is a very, very simple method, which after, I can tell you from a project we did in Taiwan last week, after 1 hour of training, people started to model their plant by their own because they actually know their plant, and within an hour they understand also what is required for them within the tool. And within a week we came out with a significant part of the plant which is already modeled, and the AI can start working on. Okay, so the ability to get your knowledge very rapidly into AI is the key for the success of the project. Because what the AI is getting out of your knowledge is basically, first of all, is understanding how everything is connected to everything. What is influencing what influence each other, and what is causing the next step of the action. So I open this valve, level there will go. When I release material, level go down, but something else will happen, and so on and so forth. We can actually, or the AI can actually go through the flow of action. Okay. So the way we use that is that we take this knowledge that you put in your language, okay, in your terminology, in the way that you call things within your plant, which is representing your knowledge, and we turn it into something which is called mathematical graph. Okay. And this is something which deviates from the, I would say, the classical AI techniques. Because now we're applying AI techniques to something which is not data. It's actually a graph. Okay. And what we try to determine here, we're trying to actually merge the AI techniques which are running on the data and which tells us that there are some anomalies. We're trying to merge them with AI techniques which are telling us these anomalies are actually meaningful. Okay? And these anomalies are actually caused by the same reason. And only when this is happening, then we'll tell the user, okay, we see that these are actually causing, you have a problem here, go check your valve or your pump, or your quality is not going to meet because of this and this thing, and so on and so forth. Okay. So actually in our case, in the SandGuard case, we're actually using AI in two different elements. One is to run, to use it to cover patterns within the data, but the other is to cover patterns within your plant, within the domain, within the knowledge that you injected into the AI. And only both of them together are enabling us to provide very focused few alerts a day, because we do not think that when you're applying AI in the process industry, which has a different characteristics than the regular AI, you cannot come with too much noise. There is enough noise in the control room. They don't need more noise. They need very, very focused alert. So if to summarize how we see the application of AI is that we basically take historical data, understand what are the normal patterns, not what can go wrong, but what's the normal patterns. And then when data comes in, we try to identify what's deviating from this normal. These are those small fires that you're seeing here. Okay? And then we apply the next stage of running AI on these anomalies together with the plant model in order to come to a decision. Okay, here you have a problem. From all these anomalies, this is actually representing a problem. Some of these anomalies are just statistical noise. Some of these anomalies is immature. This is the problem you need to focus on. And you have anything between 0 to 5 alerts a day per significant plan. Okay? So when you use AI correctly and you inject the additional knowledge that you have, but Amazon doesn't, actually you can come with a very, very, very good results. And then present it to the user in an easy way. This is basically the structure of the plant, and we really pinpoint to the parts where we think the problem is starting to develop, the parts of the processes where the problem started to develop. And of course, the user can continue, zoom in and investigate the problem and eventually come to a decision. The one thing that we cannot do today, or we don't do today in that respect, is that we do not tell the user what to do. In the process industry, from our perspective, there is a way to go before we can actually recommend. There are so many options of addressing problems that you find out about 2 weeks in advance that it's beyond the capabilities of the current AI techniques. Now, another thing I mentioned before, the issue of quality, and I just want to make another reference here to something that we call virtual sensors. And again, this is another application of AI, just because some of the data that we are using is data that is measured on lower frequency, okay, such as lab tests and so on. And some of it is the process data that we have, usually in the 1 minute interval, coming from our processes and our equipment. Now, there is a disconnect today, okay, because yes, there are attempts to measure quality in online. Some of them are successful, some of them are not. But remember the patterns that we talked about earlier. Okay. In this case, if we can merge this data in the past and find out which patterns got us into a good quality and which patterns brought us to a bad quality, and now try to understand what the difference between those patterns, and also monitor online, then we have a big win. Okay, because we have a big win because we run online and we can project that the quality is not going to be met. And that's exactly what we're doing through virtual sensor, which is basically we're trying to set the quality and other parameters as well as a function of the production data, which we do have online. And by that, do an early detection and root cause for quality issues. So this is a good example of how once you build the platform, okay, you have the data there with the AI mechanism, you have the knowledge which you injected into the AI. Now there are different kind of applications you can build on top of it, which brings you value. Because at the end of the day, what we're trying to do is to get you into improving the OEE, as I said at the beginning. I would like to kind of take this and talk a little bit about how we recommend to do to implement an AI solution, and this is basically the process that we're following. And I would really recommend to do it for you to do it, because we have gone through different hurdles and different projects until we came to this conclusion. Because there is a buzz around AI. Okay, there is a buzz around machine learning. There is a buzz around digital transformation, and all these buzz is getting to from the management up and down, and eventually drive people to do pilots. What we have found is that in many cases, even us, we didn't ask the right question about everybody's so enthusiastic, let's do a pilot, but what will be the outcome of the pilot? Now, it's very easy when everybody's enthusiastic to approve a pilot, but once you finish this pilot and your management is kind of asking, okay, what did we get out of it? Other than learning, and it was really interesting, but how much money did we save? And if you didn't ask this question at the beginning, you may not get it at the end. So we have changed our implementation process a little bit. And what we're actually doing is the first step of the project, we're doing what we call an impact analysis. And this is beside the fact that we're asking the customer, okay, what are your KPI? What are you trying to achieve? We're actually taking the data in, building small models for domain models for those parts of the plans which are relevant for those KPIs, and trying to assess whether there is enough data and enough knowledge around it so we can actually fulfill this KPI. And in some of the cases, at the impact analysis, we come to a conclusion that for certain KPIs, if we run online, this early alert will actually be very beneficial because there is something to do. In other cases, what we come to a conclusion is that during the impact analysis, we actually can conclude based on the history what were the root cause for certain things. And just by having this knowledge that some kind of heat exchanger is impacting the quality in the reactor, which you didn't think about, just by that, there is already value provided to the customer, to the plant, and from there on, you can actually monitor how this improved their operation. So impact analysis is a very important thing. It's not about technology. Believe me, it's not about technology. It's about what's your KPI, what's your targets, what data you have, and let's see that it's feasible to do that. And then, as I mentioned before, the key thing is that you need to inject your knowledge into the AI, and for that we continue to do another modeling workshop. Usually it's between 2 weeks to 1 week. And then you start running online by a week, which we monitor very closely together with the customer, train the customer through that week, and usually we recommend at least 3 months pilot. The reason being is that you want to see the effect on the plant. Okay, a 1 week pilot or historical, let's investigate some historical cases. We don't think it's the right way to analyze an AI solution, because at the end of the day, what you're required is not to check technology. At the end of the day, you need to check whether you're getting value from applying a technological solution. And this is how what we expect to happen at the end of these 3 months. And after that, of course, scaling and doing it in more plants and learning from it, and then so on is there. So if to summarize the main takeaways in the few minutes that we have left before the questions, we basically say, look at your entire plant. Okay, there is no reason whatsoever to look at certain heat exchanger, pump, reactor, whatever. There are so many things that are influencing. Some of them you don't even know. So let's do everything. We have an advantage. Let's use it. Start with what you have. I mean, you have so much data. In the process plant, there are so many tags and sensors, just because you need to control the plant, that there is no reason to now run and do all kind of, I mean, there is always place for additional sensors, additional data, but for now, this is enough. And for now, there is no, at least from our perspective, there is no reason to start all these merging of all kind of IT data in. Let's start with what you have. You have things in the historian, you have things in your pie. It's very organized. Let's use it and show some value. The plant team. These are the most important people in the whole thing. I mean, AI is not magic. If you want AI to work, you have to inject their knowledge into AI. Now, you can do it by trial and error, like I showed earlier, or you can do it in our way, in building, doing it in a very clear methodology and build a model within a short term. Whatever you decide, in any case, make sure that the plant team is involved. Keep it short. Okay, if you're running now into 1 year project, from the beginning, it's before you see any results, it won't work. This is true for every project. Don't give too many alarms. Okay, this is a true concern which we hear from customers, and we sincerely think that this is one of the keys. Because if you're going to, the process engineer is very busy as it is today without applying these new technologies. If you're going to blast him with hundreds of alarms, it won't fly, no matter how beneficial those alarms are in the long term. Okay, in the short term, you just wouldn't have time to do that. So this is our recommendation. Again, we limit ourselves to between 0 to 5 alerts a day per plant. And finally, and maybe the most important, is that AI is not for the sake of technology. It's for the sake of improving your OE. Okay, so always keep in mind, what do I want to achieve? Okay, what are my targets? What are my KPIs? And use the solution in order to meet these KPIs, and not vice versa, where the technology is leading the way. So I hope this was somehow beneficial to you. And with that, I would like to thank you and get back to people and accept some questions to be answered.
Yep, that's right. So for the Q&A, you can still send in your questions. Just send them in with the questions widget in the top left-hand corner of your screen. Click submit, and then wait to hear if they're read aloud. Okay, but I do see we already have some, so let's get started. Why can't we define a band around a process value and instruct the AI module to only show us the alerts when the values are outside of a defined band?
Okay, the thing is that first of all, you do that. Okay, you have control limits, and you set very good control limits, which if a value is beyond some kind of a limit, you give an alert. Okay, the main problem is that this value, this is too late. Okay, because you don't want to get many alerts, so you got these values or these limits very high. So you start to narrow those limits, but actually the value of one tag is always influenced by other tags. Okay, if you're doing more production, of course the pressure is up, the temperature is up, and so on and so forth. So I don't want to look only at the temperature, which is going up and down. I want to see it in connection with other tags, which are influencing that. So actually you need to look at a system. Okay, now sometimes the temperature will go a little bit up, but the pressure would not follow exactly. So we have some kind of anomaly. Now, the number of anomalies is when you look at these kind of connections between many tags, there are hundreds, at least hundreds a day. Okay, so if you look at one tag, you have to set really high limits, which are not very useful. They're useful in the control, but and if you try to limit to narrow the limits, then it means that you need to see how this tag reacting together with other tags. And then these relationships are not very exactly steady or exactly normal all the time. And then you start getting anomalies. And then you need to determine, okay, which anomalies are really representing a problem, which, it's never exactly, 100 or 1,200 degrees. It's 1,201 and 1,199, which is also in the range. Okay. So looking at one tag is not beneficial. Looking at the system or several tags together is very beneficial, but it requires you to then do something in order to understand which of the anomalies are relevant.
Okay, thank you very much. Our next question asks, how do you model a batch process where all the tags change during a batch?
Mm-hmm. Okay, that's an excellent question. So there are two things that I would say here. The first thing is that the plant model is the same. Okay, your plant is basically, you have the same machines there or the same equipment, whether you do this batch or that batch, but the data is very different. Okay, so we create a model for the plant. But then when we learn from the data, we actually divide the different learnings according to the different products which may run, or the different stages of the batch, and so on and so forth. Okay, so there may be, let's say, normality cluster for batch that is producing one product compared to a different batch which is producing a different product. There may be different behavior for the time where you load the reactors versus the time that you release the material to the next steps of the process. Okay. Now, of course, if you have indicators within the data of what's happening at each stage, that's great. If not, what we do is that we're creating virtual sensors to provide us indication of what is the stage of the plant, which is usually, you know that at a certain pressure is probably something one product or one step of the process, and another pressure is something else, and so on and so forth. Okay, so as long as you're doing something now which you did in the past, you'll be okay. The problems or our limit is that you're now doing something that you never did in the past. If you never done it in the past, then we have a really big problem. Okay, but as long as this, whatever you're doing now, this batch, this product, this whatever is happened in the past, then things will be okay.
Okay, very good. Our next question asks, do you have any case studies of successful outcomes from using the SAM software?
Sure. There are several case studies from equipment failures to issues around quality to finding root causes for things. There are several cases, mostly chemical, petrochemical, cement, paper. So all these industries are cases where whoever from the audience would like to get a specific case or specific reference, we'll be happy to provide.
Okay, very good. Our next question asks, how many sensors do you cover in a 2-week implementation?
2-week implementation is usually a significant plant with 5,000, 7,000 tags. Okay. Not all the tags are being used in the system. Some of them, like calculated tags and things like that, are not really meaningful for us. But as a rule of thumb, it's 5,000 to 7,000 tags. Now, if you're coming from a large refinery and you say, but I have many more than 5,000 to 7,000. So first of all, what is usually happening is that each process engineer is responsible for a certain unit, which is usually around that size. Okay. So in those 2 weeks, if we have 2 or 3 process engineers, we are covering, of course, the multiplier of the number I just said. So in the 2 weeks, most of the plant, even if it's for a big plant, will be covered in.
Okay, very good. Another question asking, how much historical data do you need?
This is a tricky question. Okay, the rule of thumb is 1 year or 13 months to avoid the seasonality, but it really depends on the plant. If the plant is very stable, there are no redundant systems, there are no different products that you manufacture, it may be that even 3 months will be enough. If you manufacture, let's say, two products, and one of them was not manufactured in the last year, but was manufactured a year before, then we actually would need 2 years to cover everything. The length of data is, taking as much as you have on the other side is basically what we wanted. We don't want to take too old data which reflect the plant which was already changed. For example, you did an overhaul, we changed everything in the plant, And 4 years ago, if I take 5 years of data, which of course we can't take technically, it will not be meaningful. So in the short, year is a rule of thumb. 3 months sometimes work. 2 years is kind of the maximum. Beyond that, it's not relevant data anymore.
Okay, very good. I think that about does it for today. Do you have anything more to say there? Sorry. Oh, no problem.
Yeah.
Okay. Sorry, you carry on.
Now, we have a minute left, so I think the most important thing in this context is to, in the context of the data and what would work for my plant and whether batch would work and so on and so forth, is I'm taking you back to where we are today, and this is exactly what we want to achieve through the impact analysis. Okay, because what I gave you is the general answers, which work for the companies we work with, from Valkia in Germany to Bazan here in Israel to LG in Korea to others, many others across the globe. But your plant is your plant, okay? And it may be that in your case things would work better or worse, and that's exactly what we're trying to cover through the impact analysis. Understand what can be achieved, what data you have, how this is going to contribute to your OE and to your KPI. And once this is done, the rest will just follow. Back to you, Kyle.
Okay, thank you. Yes, I think that about does it for today now. That just leaves me a big thanks for Shen and Liat for what was a great presentation, and to Precognize for sponsoring this session. Okay, so to everyone watching, you're going to receive an email shortly letting you know how to access the on-demand version of this webinar. Or you can access this through our website, which is www.business-review-webinars.com. We look forward to sharing further webinars with you, so please do keep an eye out on the website just mentioned, and follow us on Twitter at @BRWebinars Daily Updates, and join our LinkedIn group, Business Review Webinars. Thank you all once again, and I hope everyone has a very nice day.